I think one of the biggest misconceptions is that you have to be a super genius to be good at physics, and that only certain people have this like innate ability to do it. And I don't think that's true at all. I think if you work hard and you study and you're really excited about physics, then anybody can be successful in physics. The one thing we do that's unique is that we have a special first-year class just for the physics majors, or other students who are really excited by physics, and we deliberately keep the class size small so that they have more chance to interact with the instructor, more chance to interact with each other.
The learning here is much more individualized because of the smaller class sizes in the physics program. And you really get a lot more time for like one-on-one discussion with your professors. And that is incredibly beneficial. Getting that support from an individualized education from your professors, as well as the support you get from working with your peers and collaborating with your peers, bouncing ideas off of them, is really what pushes you to become a better problem solver. So I think the thing that sets the physics program here at SFU apart from the rest is that the professors really care about your learning, and you can tell. The professors are really dedicated and care that you understand the content that you're learning, and that's a really special thing.
I work with a really wonderful group of people who are very supportive of our teaching mission and realize how important it is that we do a good job teaching our students. I love it when you can see sort of the light bulb go on with a student when they suddenly have that realization and they understand something. That's one of my favorite parts of teaching.
I think that the education I've received here at SFU is amazing, thanks to the faculty and staff in the physics department and the other courses I've taken in math and stuff like that. So in a physics degree, you don't just learn about how the universe works and stuff like that. It really teaches you how to solve problems. That's really what a physicist does. It's problem solving skills. I've done 2 co-op terms actually. The first one is at Statistics Canada, and I was doing data science actually, something you probably wouldn't expect a physics major to be doing. But this is another huge thing that makes physics so valuable is that physics majors really can do anything. I think that the learning experience I got through co-op has been really valuable for me as a student, but also as a person, because it teaches you what it's like to work in a professional workplace, and you gain a lot of transferable skills like communication, and those things have helped me in student unions and clubs and community work that I've been doing.
We're really excited about getting undergraduate students involved in research. So we have a special program we call Adopt a Physicist, which allows first-year students to have research experience in the lab of one of our research faculty during their first year. It's sort of an informal program where they're matched with a research faculty member, and they get to spend time in their lab and going to their group meetings and things like that. And sometimes that leads to summer research employment opportunities and other opportunities like that. One of the tricky things with physics is it's not always obvious to people outside of physics what kind of jobs people could pursue. And so we try to, we do a very concerted effort to make sure the students know about the many possibilities. So we have a special second-year course called Physics 201, where we spend a year, it's a seminar course, talking about the various career opportunities and helping them develop professional skills so that they will be successful when they graduate in whatever kind of job they follow.
I am doing mathematical physics, so there's more opportunities since I'm kind of doing a joint major in 2 different fields. And I'm also doing a minor in computer science. So the doors are really open. I could go into computer science, I could try working at Google or software engineering or something like that. I could pursue research in physics or do interdisciplinary field, like applied mathematics or applied physics, or like machine learning is a huge thing. So there's a ton of opportunities that are open to you in a physics degree.